Hi students, welcome back to my channel Influence Mathematics. Here we are with exercise 15.1 probability, the last chapter of second terminal examination. Students, if you have not watched the previous videos, you please go to my channel Influence Mathematics, subscribe it and watch all the videos for the clearance of your doubts for the second term syllabus. Here we begin exercise 15.1, question number 5. If PE, that is probability of an event, E, okay, probability, P stands for here, P stands for probability of an event, and the event name is E, okay. You can give the event name as A, B, C, D, anything, okay. So probability of an event E is 0.05. What is the probability of not E? That means an event may be, it may be a birthday, it may be a roll number, it may be anything, it may be choosing a ball. Probability we have done last year also, right? So you know what does probability means. It is chances, right? Total outcomes will be there and the favorable outcomes will be there. So favorable outcome by total outcome, yes or no? So that is probability. Now here you are going to learn a little different things, like probability of an event plus probability of not happening that event is equal to 1. That means probability of E, that is probability of that event, okay, probability of happening that event, are you getting me? Probability of happening that event plus probability of not happening this event is same, okay. Probability of happening this event will write down like that, and probability of not happening the event we will put a bar above the event name, okay, got it? So probability of having this event plus probability of not having that event is equal to 1. Got it? Here the event name is given as E, so we are writing E. We can take, if it is not given, we can take it as our own. Okay. So here probability of E, that means probability of happening that event is given 0.05. Done? Plus we are asked what is the probability of not happening E, okay, probability of not happening the event E, we have to find out this one, got it? So probability of not happening E is equal to 1 plus 0.05 will come this side, will become minus 0.05. so probability of not happening that event E is equal to 1 minus 0.05, okay. 0, 10, 9, 10, 10 minus 5, 5, 9 minus 0, 0, 0, 0.95. 0.95 is the answer. I hope it is clear. Let's see the next question. Question number 6. Question number 6 says, see here students, a bag contains lemon flavored candies only. A bag of candies are there and which contains only lemon flavored candies, okay. So, Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? See, here, probability that she takes out an orange flavored candy. What is the event? Event is an orange flavored candy. Yes or no? We'll take number 1. Let the event of choosing an orange flavored candy be, you can give any name. I'm giving here A, okay, you can give any name. So let the event, this is the event, and orange flavored candy. This one probability we have to find out. That means this is the event. Okay. So this event name I have given as A. So probability of A equal to favorable outcome by total outcome. Yes or no? Now see here, favorable outcome, total outcome, to how many candies are there in that bag, that much is the total outcome, but that is not given to us, right? But what is given, that in the bag only lemon flavored candies are there. Whereas she is asking to pick up a candy which is orange flavored. Is it possible? Lemon flavored candy only is there in the bag. Can you put your hand inside the bag and take out an orange flavored candy from there? No, it is not possible, right? So it is an impossible event. If one also orange flavored candy is there inside the bag, then we can find out. But all the candies are lemon flavored. But here she is trying to find out an orange flavored candy. So that is not possible. It is an impossible event. Since it is an impossible event, so probability of the event is 0. Probability of the event of choosing an orange flavored candy is equal to 0. Since you will write down inside bracket, since it is an impossible event. Impossible event. Clear? Now see number 2 what it says. Number 2 says a lemon flavored candy. Okay, that is possible because in the back lemon flavored candies are only there and she is trying to find out the lemon flavored candy only, right? So let the event of choosing a lemon flavored candy be B. Okay, so probability of B is equal to favorable outcome by total outcome. Done. Now here you see one thing. I am not writing the formula here because these are the very short technique sum. For 1 mark it may come. Okay, so for short technique sum, so just wherever it is needed we will write down, but these are very short technique sum. Here you see in the back lemon flavored candies are only there. There is no other flavored candy and she is trying to find out a lemon flavored candies only. It is not that in the bag it is mixed up with lemon and orange and anything else, right? So only lemon flavored candies are there in the bag and she is trying to find out a lemon flavored candy only. So here in that case the probability is going to be 1 because here the favorable outcome, see. Now if I write down also number of favorable outcome, let me write down number of favorable outcome by number of possible outcome. Let me write down. Okay, that is the formula. Yes or no? Okay, fine. I am writing down. Now you see here favorable outcome means what we want. We want lemon flavored candy. So that will come under favorable outcome. So how many lemon flavored candies are there? That we don't know, but it is filled up with the bag. How much is there? That is there only lemon flavored candy only, right? And number of possible outcome, that means total number of candies. How much is there? That is also same because the bag is filled up with lemon flavored candies only. So what we can see, what we want and what is there, both the numbers are same. Favorable outcome, that means lemon flavored candies, how much is there? That much is only the possible outcome. Total number of candies also lemon flavored candies only. So that's why in that case the answer is going to be 1 because both are same. We can cancel it and the answer will be 1. I hope it is clear. Let's see the next sum. Here you see students, it is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that 2 students have the same birthday? Now see, what probability is given? Probability of 2 students not having the same birthday. These 2 students not having the same birthday is the event. This is the event. Are you getting me? This is the event. So 3 students keeping, and among the 3 students, 2 students birthday not having the same birthday is the probability is 0.992. Okay, we are asked then how much is the probability that the 2 students will have the same birthday. Event is same. It is given for not having, we are asked to find out for having. Okay, so event is same. So let the event of having two students let the event of having two students the same birthday be A. Done. So probability of not having the same birthday, that means bar. Yes or no? Probability of not having the same birthday. Event name is A, not having, that's why bar. Is given how much? 0.992. 0.992 is given. And what we know? We know that probability of having the event plus probability of not having the event is equal to 1. This is the formula. So probability of, we are asked to find out what is the probability that the two students will have the same birthday. Okay, we are asked to find out PA, probability of the event. And probability of not having the event is given as 0.992 is equal to 1. So probability of having the event is equal to 1 minus 0.992. It will be 0.008. I hope it is clear. Let's see question number 8. Here you see, students, a bag contains 3 red balls and 5 black balls. 3 red balls and 5 black balls. So total how many balls are there here? Total 8 balls are there. So that is the total number of outcomes. That is the total possible outcomes. Okay. So that is 8 balls. 8 is the total possible outcome. Right? Okay. Fine. Now a ball is drawn at random from the bag. From that bag, one ball is drawn randomly. What is the probability that the ball drawn is red? Number 1, red. So that ball, drawing the ball is red. That event we have to give a name. Okay. So let the event of drawing a red ball be A. Or you can give a name, different name also, R. Done. Now, number of favorable outcome. Possible outcome is ready. Even name we have given. Favorable outcome we have to write down. Number of favorable outcome. What we want? We want a red ball. Okay. How many red balls are there? 3 red balls are there. So that's why favorable outcome will be 3. Got it? Okay. So now probability of choosing or drawing a red ball. That is PR is equal to number of favorable outcome by number of total possible outcome. Okay, don't write revert. Okay, don't write the inverse of that. If you write inverse of that, the sum is wrong. Many of you are writing number of total possible outcome by number of favorable outcome. That is wrong. Total possible outcome is total how much is there. Favorable means what we want, that one how many are there. Okay, so number of favorable outcome is 3 and total outcome is 8. So 3 by 8 is the probability of drawing a red ball. Now second is what? Of drawing not a red ball. First to drawing a red ball, then not drawing a red ball. So what I told? Event of drawing a red ball is R. Right? So probability of drawing a red ball plus probability of not drawing a red ball, that means R bar, is equal to how much? The answer 1. That is the formula. Okay. So probability of drawing a red ball is 3 by 8. 3 by 8 plus probability of not drawing a red ball is equal to 1. Done. Now let's find out of not drawing a red ball is equal to what we got here. You can see 1 minus this 3 by 8 will go this side, it will become minus 3 by 8. So minus 3 by 8. So let us take the LCM. 8, 8 1 ja 8, minus 8 1 ja 1 3 ja 3. 8 minus 3 is equal to 5 by 8. This is the probability of not drawing a red ball. Got it? 5 by 8 is the answer for not drawing a red ball, and for drawing a red ball it is 3 by 8. I hope it is clear. Let's see question number 14. Now question number 14 is one of the most important sum. Here, before we start doing question number 14, here you have to know some basic things. Basic things like in a bunch of playing cards, there are 4 types. That is spades, hearts, diamonds, clubs. Okay, spades, hearts, diamonds, clubs. So these 4 types of cards used to be there. These spades used to be there 13 piece. These hearts used to be there 13 piece. These diamonds used to be there 13 piece. This club used to be there 13 piece. Done. So every category they are having 13 pieces of cards. Okay. Now in that 13 pieces of cards, what are there? In every category of 13 pieces of cards, there is 1 king, 1 queen, 1 jack. Okay, then 1 king, 1 queen, 1 jack, then 10, 9, 8, 7. The cards they will be having in this name. Okay, 1 king will be there, queen will be there, jack will be there, then number 10 will be there, 9 will be there, 8 will be there, 7, 6, 5, 4, 3, 2, and 1 S will be there, ACES. 1 S will be there. Okay, so king will be there, queen will be there, jack will be there, 10, 9, 8, 7, 6, 5, 4, 3, 2, then S will be there. In place of 1, it is S. Okay, so these are the types of cards. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 cards, 13 types of cards used to be there in each category. Okay, there are 4 categories. In every category 13 cards are there. In every category 13 cards are there, and every 13 cards is having has been divided in these 13 categories. Okay, now these spades are black in color. This is black in color. Okay, and this heart is red in color. This diamond is also red in color, and this club is again in black in color. This is black in color, this is red in color, this is also red in color, and this is again black in color. Got it? So this one also 1 king is there, this one also 1 king is there, this one also 1 king is there, this one also 1 king is there. Okay, so like that, queen also, all they have queen, all they have jack, all they have the different numbers. I hope it is clear. Now let's begin the sum. So here, students, you see question number 14. 1 card is drawn from a well shuffled deck of 52 cards. 52 cards, as I said, a deck, that means a bunch of cards is called a deck of cards, that is having 52 cards. How many cards? 52 cards. Okay, find the probability of getting a king of red color. Now see here, number of possible outcomes, total possible outcomes will be same for every sum. Okay, in this category. Okay, so how many cards total in a deck? In a deck it is 52 cards are there. 52 cards are there. Okay, now number 1, a king of red color. A king of red color. We have to get a card from that 52, and that should be a king of red color. Okay, so now number of let the event, you can give a name, let the event of getting a king of red color B, R. Done. Now number of favorable outcome. Number of favorable outcome is equal to. Now how many red colors are there? How many red colors king will be there? A king of red color, right? A king of red color. So how many king of red colors are there? Let us go once again here. See, this is red in color. This is, the heart is red in color and the diamond is red in color. Yes or no? So these two are red in colors and each they have a king. Here one king is there and here one king is there. That means one red king here, one red king here. They have not said a king of a heart. If they will telling a king of a heart, then we will get only one king of a heart. But they said a king of red color. There are two types of red colors are there. So one king of heart and one king of diamond will come. Okay. So how many kings of red color? Two kings of red color, right? So here our favorable outcome is going to be 2. So probability of the event is R, event name is given as R, is equal to number of favorable outcome, that is 2, by number of possible outcomes is 52. 2 1 ja 2, 2 26 ja 52, so answer is 1 by 26. Okay, in this way you have to do the remaining all. Okay, the remaining all. So one more point, this number 2, a face card. What is called a face card here? I have not mentioned you a face card. You will say, sir has not told anything about the face card. What is face card here? These three, king, queen and jack. These three types of card are called face cards. These three types of card, these three cards are called face cards. King card, queen card and jack card. These three are called face cards. Okay, so these three are called face cards. Now here you see number 2, a face card. Total number of possible outcome is going to be same, 52 for number 2 also. Okay, so no need to write again and again. Here you will write down only the event name you will give. Let the event of getting a face card be, you can give B or F, anything. Okay, then probability, number of favorable outcomes equal to, what will be the favorable outcome? A face card. Now how many face cards are there? See here 3 face cards will be there. Three are, these 3 types of cards are called face cards, right? So 3. So here 3 king, 1 king, 1 queen, 1 jack we will get. So here 3, here 3, here 3 and here also 3, right? So total how many we are getting? 12 we are getting. So 12 face cards are there. Total in the deck 12 face cards are there. So number of favorable outcome will be, for number 2 it will be 12. Okay, so 12 by 52 will be the probability. You can cancel and what you will get, that will be the answer. In the same way, a red face card, see, red face card. In number 2 it was only a face card, but in number 3 it is a red face card. When it is a red face card, how many red face cards are there? See, red how many? This is red in color, this is red in color. So here 3 face cards, here 3 face cards. So total how many face cards? 6 face cards, right? So 6 face cards. Here the favorable outcome will be 6. So 6 by 52 will be the probability of choosing a red face card. Okay. Now in the same way, a jack of heart. How many jack of hearts are there? Only 1, right? Jack is a category. Inside that 13 cards are there. And among that 13 cards, only 1 jack is there. So that's why here favorable outcome is going to be 1. Okay, jack of hearts. Got it? Now a spade. Now what will be the spade? How many are there spades? They have not said the category inside the spades. They have said a card you have to choose and that should be a spade. So spade, how many is there? 13 spades cards are there, right? So that's why here favorable outcome is going to be 13. Okay, a queen of diamond. How many queen of diamonds are there? Here you see diamond, 13 cards are there. Among 13 cards, these are the numbers. 1 queen card is there. So that's why 1 will be the favorable outcome for number 6. I hope it is clear. Let's see the next sum. So students, you see here in question number 16 what it is said. It is said that 12 defective pens are accidentally mixed with 132 good ones. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Okay, so 132 good pens are there, 12 defective pens are there, all mixed up. So number of possible outcome, number of total possible outcome is equal to 132 good pen, 12 bad pen. So together it will be 132 plus 12. How much it is? 144 is the total possible outcome. Now we have to choose from this 144. We don't know which one is bad, which one is good, right? It is all mixed up. So from there we have to choose a pen, and choosing that pen, the chosen pen should be good. What is the probability? Okay, so choosing a pen that is good is an event. It is an event. Determine the probability that the pen taken out is a good one. Okay, the pen taken out is a good one is an event. So let the event of taking out a pen that is good be G. Okay, so number of favorable outcomes, number of favorable outcome, number of favorable outcome. How many good pens are there? 132 good pens are there, right? So that's why favorable outcome is going to be 132. So probability of choosing a good pen, probability of choosing a good pen, that is the question. We are asked to find out the probability that the pen taken out is good. Is number of favorable outcome, that is 132, by number of total possible outcome, that is 144. So 2 6 ja 12, 1 2, 2 6 ja 12, 2 7 ja 14, 2 2 ja 4, 2 3 ja 6, 2 3 ja 6, 2 36. Done. 3 11 ja 33, 3 12 ja 36. So 11 by 12 is the probability of choosing a pen that is good. I hope it is clear. You have understood this sum. Let's do question number 17. Here you see, students, question number 17. Number 1, a lot of 20 bulbs contain 4 defective ones. 20 bulbs are there and it contains 4 defective ones. We don't know which one is the defective one among those 20 bulbs. One bulb is drawn at random from the lot. This is what is the probability that this bulb is defective. Okay, so from that lot, one bulb has been taken out, and that should be defective one. Okay, what is the probability? Okay, fine. So number of total possible outcome, number of total possible outcome. Here you don't add it, okay, 20 and 4. We are not going to add 20 and 4 because among these 20 only 4 are defective. These 4 are not separately added in these 20 bulbs. These 4 are here only. Among these 20, 4 bulbs are defective. So total how many are there? 20 only is there. Okay. So what is the event? This bulb is defective. Probability of choosing a bulb that is defective. So let the event of choosing a bulb, choosing a defective bulb. So number of favorable outcome, is equal to defective. How many are there? 4 defective bulbs are there. So favorable outcome will be 4. Okay. So let the event of choosing a defective bulb be. We have not given the event name. Let us give defective. So let us give it as D. So probability of choosing a defective bulb, PD, is equal to favorable outcome 4, total outcome 20. 4 1 ja 4, 4 5 ja 20. 1 by 5 is the answer. Clear? Let's do the number 2 of same question. Question number 2. Suppose the bulb drawn in number 1. Which one we are drawing here in number 1? Okay. That bulb is not defective. That bulb is not defective, just say now. Okay, and is not replaced also. I have taken out one bulb among those 20. So here you see, my dear students, number of total possible outcome is going to be 19, because one bulb has been taken out in number 1, right? One bulb has been taken out in number 1. So how many bulbs are left now? 19 bulbs. So number of total possible outcome is 19. Okay, total possible outcome is 19. Now the bulb which has been taken out in number 1, they are telling here in number 2 that is not defective. That is not defective. That means that is a good one, right? That is a good one, and it is not replaced also. So now one bulb is drawn at random from the rest. From the rest. What is the probability that this bulb is not defective? Is not defective. Now not defective probability they are asking. Okay, let the event of choosing a not defective, that means a good bulb, right? A good bulb be G. Okay, let the event of choosing a good bulb be G. Now number of favorable outcome is equal to, now see, total how many are there? 19. Total how many are there? 19 bulbs are there. Okay, so good how many were there here? Good how many were there? See, 20 to total 20 bulbs. Out of that total 20 bulbs, out of that 4 defective. That means how many are there good? 16 bulbs are there good, right? From that 16 bulbs, what I have done in question number 1, I have taken out 1. Which one? It is said in number 2 that is not defective. That means that was a good one. So among that 16 good bulbs, 1 already taken out. So how many are there good bulbs now? 15 good bulbs are there, right? 15 good bulbs, and we are trying to choose a good bulb only here. Yes or no? So number of favorable outcome, that is good bulb, will be 15. I hope it is clear. Total it is 20 bulbs, 4 defective, so 16 good bulbs. Out of that 16 good bulbs, 1 bulb has been taken out in number 1, okay, and which has been said in number 2 that the one which we have taken out in number 1 was a good one, So that good one, I have not replaced it back also, that I have given it to someone else. So remaining is 19. 1 has been short. Yes or no? Where it has gone? What bulb is short here? A good bulb is short here, right? So good bulb is short. So 16 good bulbs were there. Out of that, 1 now gone. So how many good bulbs are there here? 15. So number of favorable outcome is 15. I hope it is clear. So now probability of good bulb. Probability of good bulb is 15 by 19. Number of favorable outcomes by number of total outcomes, 15 by 19. Clear? Let's see the next sum. So students, that is the last sum of this chapter. Remaining you have to do it by yourself. All are relevant to each other. If any doubt, please mention it in the comment section. Let's do the last sum, that is question number 23. A game consists of tossing a 1 rupee coin 3 times. See, now 1 rupee coin. A coin has how many sides? 2 sides. Yes or no? So 2 sides a coin have. How many times it has been tossed? 3 times it has been tossed. So 2 power 3. 2 cube it is how much? 2 power 3 means 2 cube. 2 to the 4 to the 8. 2 cube is 8. So 8 is the total outcome. 8 is the total outcome. So number of total outcomes is equal to 8. Clear? Now let's see. Noting its outcome each time, Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails. That means Hanif will win if all the 3 times the toss will be head only or tail only. All the 3 times if it is head or tail, then Hanif will win. Okay? Or if one time also differing, that means 2 times head coming and 1 time tail coming, then also Hanif will lose. Okay, so that is the logic of this sum. Okay, that is the logic of winning and losing of this match. So what they say, Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. Now, for losing, he have to lose. It should differ, right? Either 2 times head, 1 time tail, or 1 time head, 2 times tail. Anything should happen. Now, so what will be these 8 number of outcomes? Total outcomes. Number of total outcome is 8. So what are these 8? See, head may come, right? Or else head 2 times coming, but the last time tail coming. Okay? Or else head coming, in the middle tail coming, then again head coming. Possible? Then again tail coming first, then head coming, then head coming. Possible? Then first also head coming, tail coming, second also tail coming, third coming head. Possible? Third, first tail coming, second head coming, then again tail coming. Possible? Done? Then first head coming, then tail coming, then tail coming. Possible? Head, tail. Possible, right? Then tail, first also tail coming, second also tail coming, third also tail coming. See, head, tail, head, tail, tail. So these 8 outcomes may come. Okay? Out of these outcomes, in this category and in this category only, Hanif is winning. So in which categories he is losing? In this 1, 2, 3, 4, 5, 6 categories he is losing. Right? So number of favorable outcome, you can give a name before the event. Let the event that Hanif lose the game be L. Okay, so number of favorable outcome, when we will lose, this 6 times we will lose, right? So equal to 6. So probability of losing the game, PL, is equal to favorable outcome 6, total outcome is 8. Done? So 6 by 8, 2 3 is 6, 2 4 is 8, 3 by 4 is the answer. Clear? That's all of the lesson. Practice well. If any doubts, mention in the comment section, or feel free to call me at the rate 8731-847-203 is my contact number. You can call me, text me, or message me in my WhatsApp also. This is my WhatsApp number too. And you can mention your doubts in the comment section too. Please do watch all the videos and mention your problems in the comment section. That's all for today. It's Nirmal Roy signing off.